All right, so we're getting ready for the Chapter 7 test, and there's a couple of questions that are most frequently missed on the test. And the most frequent one is one that feels like a trick question, but it is not a trick question. So we're just going to slow down and think clearly. So the first one is about a fair coin being flipped, and it says find the probability that the coin lands on neither heads nor tails. So I do have a student here with me that you won't be able to hear. I'm going to ask you, and you do this in your head, whoever's listening. What is the sample space for a fair coin being flipped? All right, so if you, like the student that you can't hear in this video, said to me that the sample space was heads or tails, then you are correct. And what the question is asking you is, what the probability is that the coin lands on neither heads nor tails. And I know you're thinking there's some possibilities that it got stuck in the couch cushion or something, but basically, like, a coin either lands on heads or it lands on tails. So what is the probability that it doesn't land on heads or tails? Okay, the student here with me is saying, well, that's not possible, blah, blah, blah. If it's not possible, then the probability is zero, because probability is between 0 and 1 inclusively, and this just doesn't happen. So here the probability is 0, but it feels like a trick question. So we're going to write that in. All right, so for this problem, the probability is just 0. If it can't happen, the probability is 0. The next one also kind of feels like a trick question because it throws in stuff you don't need. Remember the classic stuff in like word problems where they tell you stuff you don't need. So we're talking about the game of Sudoku, or Sudoku. I always say that wrong. And I'm a math person. I should say this right. Okay, so Sudoku. But what I'm telling you is that this is actually irrelevant. It doesn't matter what the game is. I should probably read the whole question before I tell you that. And it says that you do stuff with a 3 by 3 grid where each cell contains a unique single character number. So here we're being asked to find the probability that the number in a certain square is greater than 9. So I know that you're thinking, what is this stuff and all that? But all you really need to know is that it's a unique single character number, and we need the probability that it's greater than 9. So again, we need the sample space. So we're talking about the probability that the number in a certain square is greater than 9. We've got the sample space of all single character numbers. So for single character numbers, the sample space is just all the digits that you know. Oh, I have to have a 0 in there too, actually, now that I think about it. 0, because that's a possibility. So there are 10 digits there, 0 through 9 for single digit numbers. And this is our sample space, but it's asking us what the probability is that in a certain square, the number is greater than 9. Underline, bold. Okay, so since it's a single digit number, are there any single digit numbers greater than 9? No, there's no single digit numbers greater than 9. So again, we're going to get the same thing as above. I'm just going to copy and paste it. The probability again is 0 in this case. And what threw everybody off here was this, I can never pronounce it, Sudoku and the 3 by 3 grid that's numbers. They must be important. And all it's about is each cell. So this whole Sudoku 3 by 3 grid is just like stuff to throw you off or whatever. I don't even know why they do that, but they do. It happens all the time. So that's irrelevant. The fact that there's a 3 by 3 grid, whoop, that I drew over here, that's irrelevant. So all we need to worry about is the single, in any individual cell here, a single digit number that is greater than 9. So the probability of a single digit number greater than 9 is 0. We're going to go on to rolling dice now. And as soon as you read this, I'm hoping you're thinking what you need to know about this. We're rolling a die. So hopefully already you're thinking, oh, I know the sample space for that, and you're going to write it down. All right, so here you've written down the sample space. When you roll a die, you either think this, or you might even have in your head the picture of the 1 dot, then the 2 dots that sometimes are called, no, anyway, 1 dot, 2 dots, 3 dots, 4 dots, 5 dots, 6 dots. That's what can happen on a standard die. Okay, and we're trying to find the probability that you roll greater than a 0. Well, here is your sample space. You think you're going to roll greater than 0? Okay, my student here is telling me, well, yeah, that's the only thing you can do. So in this case, if it's certain that it's going to happen, then rather than probability of completely not going to happen, the probability here is 1. So these feel like trick questions because they're on the greater sides of probability, and they're kind of like silly questions to ask anyway. So it's just getting at, do you really understand what probability is? So since when you roll a die, the probability of getting something greater than 0 has a probability of 1. I'm sure there's some weird nerdy dice that have 0 on it. I don't know. I don't know the nerdy games that well. I should ask my kids. So here the probability is 1 because it's certain that it's going to happen. Okay, the next one is another one, the military format stuff. I know that gives some people a headache, and there's been some talk about that on the discussion board. So let's look at this really carefully. All right, so I pulled up a military clock. It's just afternoon when I'm recording this video. It doesn't matter what day it is, but it has seconds, which we're not using in this problem. We're just using this part right here. Okay, so digit, 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 which is funny. I should have used something later than this because this could be non-military time too. But so we've got these digits, and then we're not worrying about the seconds. Let's go back to the problem. Boom, there's the problem. And what we're asking for here is that the first 2 digits on the clock are greater than or equal to 0. Okay, so let's think about. So here what we really need to think about is this greater than or equal to 0, 0. And we go over here and we're thinking, well, what happens just after midnight? Is that 0, 0 and some stuff? Well, yeah, it's 0, 0 and some stuff, but like it has to be greater than or equal to 0, 0. If it's greater than or equal to 0, 0, that means it's not less than 0, 0. It's not negative numbers. Are there ever negative numbers on a clock? No, right, good. Okay, so let's go back to our document, which I think I just lost. There it is. Okay, so greater than or equal to 0, 0. On a clock, if you're in military format or any format, but whatever, it doesn't matter, greater than or equal to 0, 0, what's the probability of that? It is 1, correct. Student whose voice you can't hear on the video, and I'm sorry. The probability there is 1. This one, again, the probability is 1. Whenever the probability is 0 or 1, it feels like a trick question, and this is the most frequently missed problem on the test that's coming up for you guys, so I just wanted to go over them. So probability, again, is 1 because it has to be greater than or equal to 0, 0. There is no less than 0, 0 on a clock. There's just not. So if it's a countdown clock for the space shuttle or something, which there's not space shuttles anymore, but you know what I mean, then yes, but there's no countdown timers. This is just a regular clock. So 2 more we're going to go over that are going to feel like trick questions, but they're really not. Try to do them before me. Pause as soon as you read it. Okay, so here we're dialing a number on the keypad. Find the probability that the number you dialed is greater than 9. Think about it. All right, so you've all got phones. It's whatever century this is, we all have phones now. So it's the keypad on your phone, and here's the sample space for that. It's the same as it was up here, so I'm going to copy and paste it. Okay, so probability that we're greater than 9 when we have the choices of the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Can we be greater than 9? No, we cannot. So the probability is 0. All right, last one. All right, here we have die, rolling a standard die again, just one standard die. So let's put the sample space in. All right, we put in our sample space of 1 through 6 again for rolling a single die. We're looking at the probability that the thing that you get when you roll the die is less than or equal to 6. Well, how much of this is less than or equal to 6? Yes, all of them. So you could write 6 over 6, but again, this is just one where like it's definitely going to happen. You're definitely going to get something less than or equal to 6. So the probability on this one is 1. And these are all the kinds of questions I think you could get on the test. There's other ones. I'm not going to give you every single possible thing that could happen, where it's going to feel a little bit like a trick, but it's really not a trick. It's just really go slow, think about it, and be patient with yourself. I hope this helps you not get tripped up on the test, and take care of yourselves and write down good notes.